Hey, so welcome back, and this is another daily LeetCode problem. So today it's called Spiral Matrix 2, and actually yesterday's problem was called Spiral Matrix, so it's kind of it's the second version of it. So very similar algorithm, they just change it up a little bit. So yeah, let's get started. So it's a medium level question, and it's pretty popular. It's 5,000 upvotes, and all that you want to do is you're given a particular number n, and you want to construct an n by n array. And so it's a two-dimensional matrix with n rows and n columns. And basically you just want to populate this matrix. Oh, my music's a bit too loud. You want to populate this matrix so that in this kind of spiral order, it increments by 1 each time. So if you kind of followed it, you'd expect it to be incrementing by 1 each time. Okay, so, I'm gonna not show you this yet, but we're gonna take a very similar approach, or the same approach that I did yesterday, where all that you have to do is you have 4 different variables that you're keeping track of. And that's just like the starting column, which is this one here, the ending column, the starting row, and the ending row. And you just kind of move these pointers around as you populate this matrix. So first you start off with populating the top row here from left to right, then from top down, then the bottom row from right to left, or from the right side to the left side, and then up, and then you just kind of keep repeating that algorithm. So yeah, let's go ahead and implement this. So first we'll want to make that matrix. So we'll just call it MAT for short for matrix. And in Python, it looks like this, where we initially set it to 0, and we have n columns, and we'll have n rows. Okay, and so that's our matrix, and at the end of this, we're going to want to return it. And then we want to have those 4 different pointers. So we have our starting column, our ending column, our starting row, and our ending row. And that will be equal to, let's see, 0 for the starting column, since it starts at column 0, and then n minus 1, since it's like non-inclusive. And then we just repeat that for the number of rows, since they're exact same. Great. And so now we'll have our core kind of algorithm that we're going to implement here. And the first thing that we want to do is find out what's kind of our exit case, or when we stop computing this result. And that's going to be whenever the starting column or the ending column, or starting column or starting row, overlaps with the ending column or ending row. And that looks like this. So while the starting column is less than or equal to the ending column, and the starting row is less than or equal to the ending row. Great. And so we want to just keep processing while these remain true. Oh, and forgot to call that end row. Okay, and so we'll then have our 4 different cases, which is like left to right, top down, right to the left, and then bottom up. Okay, so first one is, let's go from the left side to the right side. And that's going to be, okay, for every column in a particular range, which is from the starting column to the ending column plus 1. Fantastic. And we're just going to be populating this matrix as we go. So for every column at the starting row. So this is the starting row because we want the top row, and we're just kind of populating it from left to right with this index here. Okay, and that's going to be equal to, and we'll just call it current, which will be a variable tracking the current number that we're on, which it initially starts at 1 here. Great, and so that's the first case. And now we want to basically repeat this logic 4 different times, and we'll just modify it with each iteration, or with each case. And so this next one is from top down, and we want to go through every row here in the range from the starting row to the ending row plus 1. Okay, and so we want to iterate through all of these rows with this variable here. And we want to use the ending column because we want the rightmost column. And that will be the current. So after each iteration, we want to be incrementing this value by 1. That way, so as we're going from left to right, we keep populating these values and increment our current by 1. So that does that here. Same thing in this case. We want to be incrementing this by 1 each iteration. Okay, and so let's copy this another time over for our next case. And this will be from the right side to the left side, which will look like this. Great, so from the right side to the left side. And this will be, okay, let's go through every column in the range of our ending column, since we're starting from the rightmost column, to the starting column. Let's see, starting column. And we want -1, since in Python it's like non-inclusive. And we add a -1 here since we're going backwards. Okay, and then we want to iterate through the bottommost row, which is the end row here, and every column. We want the end row because we're, oh, let's see, is that right? This is, no, what we want, yeah, we're going from the right side to the left side, that's right. We want the ending row because we're using the bottommost row. Okay, and that looks good. And so then finally we have one more case here, and I'll have to do one other adjustment, but I'll just move me down here. Okay, and let's place that here. And now we just want to go from the bottom up, so top, and wait, no, this. From the bottom to the top. There. Okay, and so we want to go through every row from the ending row to the starting row, and we just do -1s, and then we want to go through every row here and just be on the leftmost column, since we're going up on this left side, which will be the starting column. Great, and we once again just want to be incrementing our current by 1 each time. So there's 2 extra things that we have to consider. One thing is, as we're kind of traversing this topmost row and then down this rightmost row, we're kind of bringing in those bounds because we're shrinking the size of the array that has been populated or hasn't been populated. And so to do that is, after these iterations, we want to be kind of closing in these parameters. So when we evaluate the topmost row, let's set our topmost row, the starting row, and bring it down 1. So now the topmost row is 1 step lower, since we just evaluated row 0 here. And then similar thing here on this case is, when we go on the rightmost column, we want to bring our ending column inwards, which is this. So this rightmost column goes inwards. And then similar thing here, when we do the bottommost row, we want to bring our ending row up 1, so we subtract 1 by it. And then finally, we just want to do the leftmost column, so we want to bring in the starting column up by 1. Okay, and so that's all good. We just have one other thing, and that's, okay, as we're bringing in these bounds, the starting row and the ending row, these might not need to be evaluated. And so because this while loop is kind of very long, like this case should be checked multiple times here. And so we just want to include this check at these additional points here. So if this case is true, then let's evaluate that condition, and same thing here. Okay, and let's try and run this. Looks good. And submitted. I'm surprised there's no bugs there. Just there's a lot of code here, so it's easy to mess one of these conditions up. So for time and space complexity, it should be pretty natural to assume that, okay, since we're producing an n by n matrix, the time complexity would then be, or the space complexity would then be n squared. And I'll just write it out so there's no confusion. So n squared, which you might be used to this notation. And then for time complexity, it's the exact same thing. And that's because, well, we're just going to iterate through every cell at most once. And because the cell is an n by n matrix, it'll be running n squared time. Okay, so yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks for watching.